All right, so I'm going to talk about double angles. Right here, I have the two formulas for double angles that I'm provided on my formula sheet for our DA. If you look right here, I've got sine 2 theta is equal to 2 sine theta cosine theta. And then I've got cosine 2 theta is equal to cosine squared minus sine squared. So those are the two that I'm given. So this is the only one for sine. I have two other ones that I can use for cosine though, and those are better for solving. If I'm just evaluating, so if I'm given, just solve for sine 2 theta equals this or whatever, then I'm going to want to use one of these equations. But we know that cosine squared is equal to 1 minus sine squared, right? So what I can do is I can change this cosine squared into 1 minus sine squared. So I've got 1 minus sine squared theta. And then I'm just going to bring down the minus sine squared theta. And so now I have another equation where I'm just going to go ahead and combine like terms. I have two negative sine squareds. So I have 1 minus 2 sine squared theta. And that's going to go ahead, that's going to be one of my equations for cosine 2 theta. The other one, we also know sine squared is equal to 1 minus cosine squared. So I'm going to replace this sine squared right here. And I'm going to go ahead and go cosine 2 theta is equal to cosine squared minus 1 minus cosine squared. Okay? So I went ahead, I was sure to write the 1 minus cosine squared inside parentheses right here, because with the sine value right here being subtracted, it's important that I subtract all of sine squared. And sine squared is equal to 1 minus cosine squared. So if I didn't put all of that into parentheses, then I wouldn't actually have the correct information and I would just be subtracting 1. So now I'm going to go ahead and distribute that subtraction sign. And so now I get cosine squared theta minus 1 plus cosine squared theta. I apologize. There's some sort of lag as I'm writing this, and so it's not writing as I'm actually writing it. So it's kind of screwing things up a little bit. So right here I end up with cosine squared plus cosine squared, which gets me 2 cosine squared minus 1. So my cosine 2 theta is equal to that as well. Okay, so I've got those three equations. So I've got the first one, second one, and third one. Those are the three that you have for cosine 2 theta. Again, you're only going to be given these two right here at the top that I started with, the two black ones here. Those are the only ones that you'll be given on any quiz or test or DA, okay? So let's apply this information. If this is what I was given, cosine of theta is equal to 8 over 17, where theta is between 0 and pi over 2, I need to find cosine 2 theta. So let's break this down. So this is telling me where I'm at. I'm located in this quadrant between 0 and pi over 2. Well, 0 and pi over 2 is going to put me in my first quadrant right here. Okay? And here's my theta. Because don't forget, theta is always between your origin and the x-axis. It's always going to be, or not between them, but it's always going to be touching the origin and the x-axis. Okay? So I'm going to go ahead and put this in here, cosine. Cosine is adjacent over hypotenuse. So here's my adjacent and here's my hypotenuse. So I've got 8 and I've got 17. Okay? What I need to do, I need to go ahead and find the missing side here. I'm just going to use Pythagorean theorem. I've got 8 squared plus b squared equals 17 squared. Okay? When I go ahead and solve for b squared, I get not b squared. When I solve for b, I get b equals the square root of 17 squared minus 8 squared, and that's going to end up getting me b equals plus or minus 15. Yeah, 15. All right. So that means that this side right here is 15. Okay? So now I have all three sides of my triangle, so I can go ahead and put it into my equation. Now I have three equations for cosine 2 theta. The easiest one to use when doing this format right here is to go ahead and put it into the equation that's like this, the one that you're given to start with. Okay? So right here, if I was going to go ahead and do this, cosine is 8 over 17, so I go ahead and go 8 over 17 squared minus sine squared, 15 over 17 squared. Okay, so I've got 8 squared is going to get me 64. 17 squared is going to get me 289. 15 squared is 225, and again 17 squared is 289. So I've got 64 minus 225 for my numerator, and that's going to get me negative 161 over 289. So that is the cosine of the double angle that I'm given. So initially I'm given this angle, and I'm doubling it. So I'm doubling whatever this angle is. I don't know what this angle is. I know it's side measures though, but I don't know what that angle measure is. Sure, I could find what this side measure is by using an inverse function or an angle measure, but I'm not worried about that. But I'm doubling it, and that's what its cosine value is once I double that angle, okay? I could use one of the other two equations if I wanted to. I don't need to. If I use this one, like so right here, I'm given 2 cosine squared minus 1. Since I start with cosine, let's go ahead, we'll do this way, and you can see that it's really not that much easier at all. In fact, it makes it more challenging. So I'm going to go ahead and write the formula. Why won't this go down? Okay, write the formula out. So I've got cosine 2 theta is equal to 2 cosine squared minus 1. Okay? So I'm going to take this, put this in. I've got 2. We were given cosine up here, 8 over 17. So I'm going to put that in here, 8 over 17 squared minus 1. Okay? So now I'm going to go ahead. Order of operations says I square first. So I've got 2 times 64 over 17 squared, which is going to be, 17 squared, which is 289 minus 1. Now I've got to multiply. Order of operations says I multiply, so I'm going to go straight across. 2 times 1 is going to get me, 2 times 64 is going to get me 128. Ooh, lag. 128 over 289. And I'm going to subtract 1. Well, if I'm subtracting fractions, I have to have a common denominator, so I'm going to put this over 1. And we're going to multiply by 289 to both top and bottom to get a common denominator. So really I have 128 over 289 minus 289 over 289. Once I take that and put that in my calculator, 128 minus 289, I get negative 161 over 289. So you see I get the exact same answer, negative 161 over 289 for both of these right here, right? But one of these ways is way easier than the other. This one, because it's already going to go ahead and give me a common denominator. Because if I'm doing cosine and sine, so cosine is adjacent over hypotenuse, and sine is opposite over hypotenuse, I'm always going to have the same thing in my denominator. So I don't have to worry about getting a common denominator. So that's going to make my life a lot easier. So this is the method that's best to use in questions that are like this. Popular question I get is how to do a question like this one, where if I'm given tangent, I'm not asking you to solve for tangent, but I'm given tangent. So first and foremost, let's figure out where we're at. So this says I'm between pi over 2 and pi. Well, pi over 2 is here and pi is here, so I'm in my second quadrant. Here's my theta, again, touching the origin and at the x-axis. So tangent, this is opposite, this is adjacent. So my opposite is 4, my adjacent is 3. Notice this is negative. It's not saying both of them are negative, and it's not saying the 4 exclusively is negative. It's saying one of them is, and I have to determine which one. Because I'm in the second quadrant, the 3 is the one that's going to be negative, because I'm going left. This 4 represents going up. That's my y, and that's in my second quadrant. So x's are always negative in the second quadrant, and y's are positive in the second quadrant. So this is what I have. If I was to solve for my missing side, I'd use the Pythagorean theorem, which I shouldn't have to do here. I should recognize 3, 4, and therefore 5. Okay? So now I'm going to do sine 2 theta, which the equation for that one, sine 2 theta, is 2 sine theta cosine theta. I could also do 2 cosine theta sine theta. It doesn't matter. Order doesn't matter. I'm multiplying. It's all the same thing. Okay. So if this is what I have, I'm going to go ahead and fill in. So I've got 2 times sine. Sine is opposite over hypotenuse, so I've got 4 over 5. And cosine is negative 3 over 5, so negative 3 over 5. So I'm going to go ahead, I'm going to multiply straight across. 2 times 4 is 8. 8 times negative 3 is negative 24. 1 times 5 is 5. 5 times 5 is 25. So this right here is sine 2 theta of this angle. So again, this is if I just doubled this angle, this would be the sine of that new angle that I have. So it's really not too bad. It's more just figuring out which quadrant you're in, finding the missing side by using Pythagorean theorem, and then plugging it into the equation. It's not more complicated than that. Don't overthink it, okay?